This video is about Maclaurin series. Question 1. Let f of x equals 1 minus ax to the negative 1/2 power, where ax less than 1, a is not equal to 0. The nth derivative of f of x is denoted by this. N is a positive integers. Prove by induction that nth derivative of f of x equals this. Math induction. We will use a CAP method. Check it's true for n equals 1. A means assume it's true for n equals k. Third, proof it's true for n equals k plus 1. So first step, check it's true for n equals 1. The first derivative equals, let's do the substitution, a to the first power times 1 factorial times 1 minus ax to the power of negative 3/2. Denominator 2 to the power of 1 times 1 minus 1 factorial. We do know 0 factorial equals 1. Organize. We got a/2 times 1 minus ax to the power of negative 3/2. Then for f prime of x also equals 1 minus ax to the power of negative 1/2 prime. We do know u to the power of n prime equals n times u to the power of n minus 1 times u prime. When n equals negative 1/2, we got u to the power of negative 1/2 prime equals negative 1/2 times u to the power of negative 3/2 times u prime. Let's substitute u with 1 minus ax. We got negative 1/2 times 1 minus ax to the power of negative 3/2 times u prime means 1 minus ax prime equals negative 8. Simplify. a/2 times 1 minus ax to the power of negative 3/2. So it's true for n equals 1. Second step, assume it's true for n equals k, which means we will change every single n into k. Kth derivative of f of x equals every single n, we will change it into k, a to the kth power times 2k minus 1 factorial times 1 minus ax to the power of negative 2k plus 1/2. Go to denominator 2 to the power of 2k minus 1 times k minus 1 factorial. Third step, proof it's true for n equals k plus 1. We will change every single n into k plus 1. We got k plus 1th derivative of f of x equals every single n you will change into k plus 1, a to the power of k plus 1 times. Let's work this out. 2n minus 1. Change this into 2 times k plus 1 minus 1, which is 2k plus 1. 2k plus 1 factorial times 1 minus ax to the power of negative. Now we will change this 2n plus 1 over 2 into 2 times k plus 1 over 2, which is 2k plus 3 over 2. 2k plus 3 over 2. Go to denominator, 2 to the power of 2n minus 1. This n we will change into k plus 1. 2 times k plus 1 minus 1 equals 2k plus 1. Then times n minus 1 factorial, we will change it into k plus 1 minus 1 equals k factorial. K plus 1th derivative of f of x equals kth derivative of f of x prime, which means go to this assume, do the substitution. A to the power of k times 2k minus 1 factorial times 1 minus ax to the power of negative 2k plus 1 over 2 over 2 to the power of 2k minus 1 times k minus 1 factorial prime. The coefficient is this. So we bring down the coefficient, which is a to the power of k times 2k minus 1 factorial, 2 to the power of 2k minus 1 times k minus 1 factorial. We will do the power rule for this. Drop down the exponents. Negative 2k plus 1 over 2 times 1 minus ax to the power of negative 2k plus 1 over 2 minus 1. Do not forget the chain rule. 1 minus ax prime equals negative a. Then we organize. First of all, let's check the sign. Negative is positive. Then a to the kth power times a is a to the power of k plus 1 times this 2 as a denominator. So 2 to the power of 2k minus 1 times 2. Add exponents, we got 2 to the power of 2k. And simplify this. Negative 2k plus 1 over 2 minus 1. Let's move this negative sign to the top. we got denominator is 2. Negative 2k minus 1. Denominator over 1 times 2 times 2. So minus 2. Simplify. Negative 2k minus 3 over 2. Let's check this proof part. We need negative 2k plus 3 over 2. Negative 2k plus 3 over 2. Then times 2k minus 1 factorial times 2k plus 1. Denominator, we got k minus 1 factorial. Now compare these two. We need 2 to the power of 2k plus 1. We got here is 2 to the power of 2k. So we need to times 2 to the top and bottom. We need a k factorial as a denominator. But we got this k minus 1 factorial. So we times k to get this k factorial. Then you have to times k on the numerator. Always keep this in your mind, because this is the final form we need to get from this. We do know factorial 1 times 2 times 3, keep going, k minus 2. Then we call this is k minus 2 factorial. Next term times, keep adding 1, k minus 1. So this is k minus 1 factorial. Next term times k. Then we get k factorial. For 2k minus 1 factorial, next term add 1 will be 2k. So we get 2k factorial. Next term 2k plus 1. Then we got 2k plus 1 factorial. Therefore, for k minus 1 factorial times k will be k factorial. Numerator a to the power of k plus 1. Now 2k minus 1 factorial times 2k. This is 2k. It will be 2k factorial. Then times 2k plus 1. It will be 2k plus 1 factorial. Then times 1 minus ax to the power of negative 2k plus 3 over 2. So it's true for n equals k plus 1.